Today we'll be going through the 9709 Paper 1 Pure Mathematics paper, May-June 2023, Variant 11. Alright, so the first question, they're asking us to solve this trigonometric problem, and straight away we can see there's a tan theta. And when there's a tan theta, you're immediately reminded of tan theta equals to sine theta over cos theta. So that's just a very well-known formula that you need to remember. Okay, and then you just continue solving it, and I've made the denominators the same so that I can link the numerators together in one line and just continue solving from there. Now, at this section, when you see sine theta inverse 0, you're basically trying to find out what angles will give you 0. Okay, so when you face this problem, you would want to remember this graph. So I remember there's a good mnemonic for this, and it's basically all science teachers are cute. So all sine, tan, cos. Now we all know that this is 0 degrees, 360 degrees, this part is 180. So what angle will give you 0 when you put in the angle at sine, right? So obviously when you put in 0, you're going to get 0. That's what it shows on the calculator as well. However, if you look over here, if you key in 180, it's going to give you 0, right? Then if you go a full loop, you're going to get, if you put 360, you're going to get 0 again, right? So over here, you can put in 180, 360. And then for the cos formula over here, we can see that it's a negative, right? You see I've left out the negative here. That's because I want to find the critical angle. So if you key into your calculator cos inverse 1 over 4, you're going to get 75.522. But that's not what I want. I want to know what is negative, right? So again, if you look at this graph over here, okay, you know that any angle within this section quadrant will be positive because this is your cosine quadrant, right? However, if you have an angle over here or over here, you're going to get a negative value for your cosine. So you know your critical angle right now is 75.5. This will give you a positive if you sub in cos 75.522, right? You're going to get a positive 1 over 4. You put key into your calculator to check that, and that's true. Okay, but then if you want to find out what's your critical angle over here, you want to find a negative, right? So what I want is this angle here or this angle over here. However, because we know that the domain is within 180, we know I don't want to find the angle that will reach up to tangent quadrant. So all I want right now is this angle over here. And how do I find that? Well, you know this is 180. So to find this angle, you would need to do this part is your critical angle. It's the same as 75.5. So what you need to do here is 180 minus 75.522 to find this angle. Okay, you have 180, you're minusing this part off to find this angle, and that will be in your sine quadrant. So that makes your value when you sub it into cos as a negative 1 over 4. So let's type that in. You're going to get 104.5. I've rounded it up to 1 dp. Okay, let's move on. So find the first 3 terms in the expansion in ascending powers of x of 2 plus 3x to the power of 4. So when you face these kind of expansion questions, right, you would want to first factorize out anything that's not giving you a 1 in this position. Okay, so over here you can see there's 2 plus 3x. I don't want that. I want there to be a 1. Okay, because only when you have a 1 can you use the formula that's given in MF19. So what I'm going to do, I'm going to factorize out the 2. Still, I'm keeping this 4 on the outside, okay? I'm not doing anything with the outside because I'm factorizing only the inside. So after I factorize the inside, it makes it much easier for me to then move out the 2. And when I move out the 2, right, I move it outside here, it's gonna give me, I need to remember the power 4 here. That's why I put a bracket and another bracket here and then a 4. So when I move it out, I need to remember to carry the power of 4 with me. So from here, ignore this part. Obviously, just still write it in here, here, here. But you can ignore that. All you need to do is apply the MF19 formula for these steps onward, okay? So after you've applied the MF19 formula, you can then just continue solving and simplify it into the final equation, yeah. Okay, moving on for B, find the first 3 terms in the expansion in ascending powers of x of 1 minus 2x to the power of 5. So once again, this part, your 1 is already a 1. So that makes life so much easier. That's why it's only 2 marks. Well, the top one is 2 marks too, but it's much easier because it's part B already, so you already know what to do. So when you have 1 here, you can just use the formula and just continue simplifying it from onwards. Hence, find the coefficient of x squared in the expansion of 2 plus 3x to the power 4, 1 minus 2x to the power 5. You need to recognize that, since you already see a hence, it's a follow-up question, right? So you need to recognize that we've already solved the first 3 terms here, for these 2 separate equations. So what I did was I copied this term over here, and I copied this term over here. So then I just need to find x squared, right? So what I did, you can see by my color coordination, I just multiplied the terms that will give me x squared. So 16 times 40x squared, 96x times negative 10x, 216 times 1. Then you just simplify it from there. So for question 3, the question's asking for transformation, right? So in these questions, it's actually, you need to be able to identify which type of transformation, right? And it's actually pretty easy once you get the hang of it. So in the first off, we notice that it's much longer and bigger than the original. Your gx is much longer than your fx, right? Okay, you notice the length in terms of the x-axis is the same. 2 boxes here, 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 2 boxes here. Okay, so now there's no stretching in the x direction, but can you see that there's a stretch in the y direction? So over here you can see there's 1, 2, 3, 4 boxes. Over here there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've stretched in the y direction. So what you want to ask yourself now is how much has it been stretched, right? So there's 2 boxes here, 4 boxes here, 4 boxes here, 8 boxes here. And if you don't want to count, you can always just look at the coordinates. So over here you have 3, 3. Over here it is -1 and -3. So we know the x-axis hasn't been stretched, but we know the y-axis has been stretched. So you're looking at the same point, right? And what you want to identify is your y-axis. So once again, you can see 3, -3, -6, 3, and -3 and 6, right? So you can see there's a stretch factor of ×2, because 3 times 2 is 6, and -3 times 2 is -6. So your stretch factor is 2 in the y direction. So next, if you stretched it and there is no translation, it would just remain in the same spot. But we can see that it has moved from its spot, and now we want to find out how it has been translated. So even if it has stretched, right, you're gonna get something like okay, but it has obviously moved from there, and if you're looking at, you have to look at the same points. So this point to this point, you move to the left by 6 boxes, and so when you move to the left, you need to remember the negative sign. So that's what I did over here, and remember, put it in the vector form. So the top place is for moving to the left or to the right, and the bottom place is moving up or down. Up is positive, down is negative, and right is positive, left is negative. So in the fourth question, we ask a circle theorem question. You need to remember these two formulas. Okay, most of the time they ask for those two. They ask questions that involve using those two formulas. So we're asked to find the perimeter of the segment BCD. And we know the radius is 8 cm, they've listed it here for us, and the area of the sector is 16 pi over 3. So we're asked to find BCD, right? BCD, this sector over here. And obviously we would want to find the arc length first because its formula is pretty easy, r theta. We already know r, but we don't know theta. However, we know that the area of the sector is 16 pi over 3, so we need to use this formula to find the theta. That's what I did over here. And then for the second step, I want to find the arc length BC, and that's what I did. I substituted r equals to 8 and theta equals to pi over 6, and that's what I found. And then for your length BC, you want to I use the cosine rule, so that's the a squared equals to b squared plus c squared minus 2bc cosine theta, and that's what I found because this is a triangle. Okay, and then I just added it all up together because I just want this part and this part, right? I found length BC, I found arc BC, and that's what I want. So perimeter, there you go. So in the question 5, we are asked to find the value of k and the coordinates of the point where the tangent meets the curve. So we have the line with the equation, we have the tangent equation, and when it comes to these kind of questions, you already see tangent meets the curve. Very familiar, b squared minus 4ac, you need to use that, that's your discriminant, okay? And then when you find when you see the word meet, it often involves the intersection point, right? So what I did was I equated these two equations together, and then you get this. You see k and you don't know what to do. But remember discriminant, when you see tangent meets the curve, it's where b squared minus 4ac equals to 0. So what I did, I substituted my b value, which is 2k, and then I substituted a as minus 2k and c as negative 1. And then you just carry out the formula, and eventually you get k equals to 0 and k equals to 2. However, we know that k is a positive constant, so we only accept k equals to 2. Remember to write rejected.